Okay, we're doing a little bit more testing here today with our test stand, and the purpose of today's test is going to be to produce a battery discharge versus voltage curve for this motor and gearbox and double propeller setup here, for the purpose of calibrating a system that'll work with the airspeed system in order to report the amount of charge remaining while the airplane is flying. So we're going to take a series of runs of about a minute each, and we're going to stop at the end of each minute period and check the voltage and the charge state. And in the meanwhile, we're going to monitor the amount of thrust we're producing and the amount of current that we're using. So there's this meter shows the voltage in the charge state. We're starting off at 24.92 volts, and that's just on one of these batteries. The batteries are actually connected in series, so the total on the motor is twice that. And this device will measure the current flowing through the motor and allow us to calculate the amount of power that the motor is demanding at any one time. All right, let's go ahead and start for the first.
Okay, start.
The first minute. Yep. Okay, go ahead. Gearbox is hot now. So we're at 23.53 and 64%.
Half throttle.
Right, so go ahead and give it that other minute at half throttle.
Okay, hang on, let me get the clock set here.
Something's going wrong. Unless you're doing that.
No.
Okay, well there's something going wrong.
Well, there was a clunk there at the start. Did you hear that something at the start?
What's that?
Something clunked at the start.
Yeah, I heard that. I don't know why, but I think we're
You better look inside.
I think
that
we're
gearbox.
having an internal problem with the gearbox.
Okay, well let's take it apart and look at it. I don't want a chance of fucking the gearbox up any worse. I mean,
Right.
all it's going to cost us is time. And
Yeah,
if it'll fly Sunday, then it'll fly the Sunday after.
Right.
I mean, I don't want to fuck this thing up just to.
No, I agree. We'll pull it apart and see what the situation is. Okay. We've taken the gearbox apart. You can see on the inside of it here And I've discovered what the problem is. The gears themselves are fine. The shafts and the bearings are all fine. But, let me put a light in here. But the problem occurred with this little bearing retainer here, which this is a thrust washer. It goes right there to bear against that thrust bearing, and then this thrust washer fits inside and holds that whole thing in place. And I had that fixed in there with Loctite 680, and I think what happened is that the 680 let go, and it probably just got too hot for it. And obviously I'm going to have to come up with a better mechanism to keep that bearing retainer fixed in there. Well, I'll go ahead and tear the rest of the gearbox down and look at the top end of it as well. All right, here's the parts broken down pretty much completely. And the problem, once again, is this little bearing retainer and its connection to the inside of this shaft right here. That's going to have to be, I'm going to have to redesign somehow. The problem, of course, is that the other shaft goes through the center of it and leaves very little clearance. The annular clearance in there is really low, so there's not much room to do anything, which is why I used Loctite in the first place in order to get this thing to fasten together. And I'm just going to have to come up with a different mechanical system in order to fix this bearing retainer into the back of that outer shaft. So there it is, and that's what the gearbox looks like on the inside. Okay, so I think that the right way to deal with this now is, if you look at this end of the shaft, the thickness of this outer shaft is thicker, except for right where I actually cut down the inside of it to make this bearing retainer slide on the inside. I think what I need to do here is simply leave this shaft at full thickness and then cut some threads on the outside for about the top, maybe 1/8 of an inch or so, and then remake this piece without this sleeve that goes in here, but just be like a washer with threads on the inside. So it would go on here once these other parts of it were assembled. That's where the thrust bearing goes. Then it would go on here and simply screw on to the back of that shaft, and it would fix itself that way. And I think maybe that's the right approach to doing this.